Welcome to another podcast. In this episode, we're going to be taking a look at a specific ordinary annuity example. In this particular example, I want to start by acknowledging the revised formula I have over here to the side. Recall that when we looked at the previous video, we had the partial sum of a geometric series was given by A times, it ended up being 1 minus r to the n over 1 minus r. If you replace r with 1 plus I, where I is the interest rate per period, and you replace n with nt, then you end up with this formula. Notice it's 1 minus, so if I switch both the top and bottom, I end up with the formula over here on the right-hand side. We could go through the algebra to show that. That's not that big a deal, but I'm more interested in, now that we have this formula, do you know what the different pieces are? A is the future value of the ordinary annuity. P is the payment size. So this is the recurring payment size. Remember, for an annuity you have equal payments at equal time periods. So a recurring payment. I is the interest per period. Specifically, you can think of I as R over N. N is the number of payments per year. And I know what you're thinking, well, wasn't N the number of compounding periods per year? And it was when we were doing compound interest, but because the compounding periods coincide with the payments for an ordinary annuity, then it's just better to think of it as the number of payments per year for an annuity problem. T is the time in years. And together, that is the formula for the future value of an ordinary annuity. Now, we want to apply that formula to this problem, and so what I suggest is we go through and list for each variable what the values are, and then we'll take a look at how to solve it in the calculator from there. So, starting with the future value, it wants to know what would the account be worth after 40 years, and that is asking what is the future value. So I'm just going to leave that question mark for now. We're going to have to come back and solve for that. What is the recurring payment? Well, if you're spending $100 per month on cigarettes and you decide to invest that money instead, then the $100 is the recurring payment amount. And then the interest I per period is 4.8% or 0.048 divided by N, which is the number of payments per year, so it's 4.8% divided by 12. So that would be our I value. And then our N value is the number of payments per year, which is 12. We're making monthly payments. And then the time, well, this account's going to run over a 40-year term, so there's going to be 480 total payments, or 40 total years worth of payments. If I plug all this into the formula, then I'm looking at the following. So we've got 1 plus I raised to the 12 times t. So this is where the 480 that I was talking about comes from before. That's the exponent here tells you the total number of payments. So minus 1, and then in the denominator we have the 0.048 divided by 12 once again. Alright, so the best way to handle this is to do it all at once in the calculator. So I've gone ahead and done that for us. Notice that with the color coding of the parentheses, you can make sure that you have everything exactly how you want it. So, follow along at home, try to enter it into your calculator, make sure that you can enter it like we have in the formula here. And what we discover is we get a value of $144,872.14. So, $144,000 $872, and to the nearest cent it would be 14 cents. So that's the answer to the question, but I actually want to dig a little bit deeper. So I have sort of a follow-up question here, and the follow-up question is, how much of the future value is principal and how much is interest? So the principal part refers to the amount of investment that I've made. So the principal is your money or my money. So how much of my money did we put in? Well, we made a $100 payment every month. For 40 years, 12 payments a year. So if you multiply through there, we're going to get $48,000 was our money. But the overall amount is $144,000. So where did the extra money where did it come from? Well, it comes from the interest that's earned on each of those cash flows. And so the interest here is the difference between the future value and the money that you put in. And we know the future value is $144,872.14, and the amount of money that you personally put in to the account is $48,000. And so when you subtract those two, so bring in the calculator once again. So we've got 144,872.14, and we're going to subtract the 48,000. So it's $96,872.14. This is the amount of money earned by not smoking. Because you already had the $48,000. You can choose not to smoke, so you save that money. But this is sort of the opportunity cost. You'll hear me use that term in class. This is sort of the opportunity cost of not smoking for this example. The idea being that I could make a lot of money on the money that I'm spending on things like cigarettes. And this is true of a lot of things. It's not just cigarette use, right? You think about fast food and things like that, things that you spend money on that aren't necessities. That money can be saved, and over the course of 40 years, it turns out to be a significant amount of money. So it's just something I want you to think about as we're working through a lot of these examples. What is the opportunity cost of the money that we're working with? Now, before we close, I just want to, those of you that are using the finance commands, which I completely encourage, I just want to show you what the command would be for that and show you that we end up with the same future value. Remember, the finance command is the present value, then the future value, then the payment size, then the interest per period, and then what I called capital N, which is really just the total number of payments. So the finance command here for this problem, we would have to put in a principal amount of 0 because I'm not, there's no initial investment. So there's no money initially in the account. I'm going to solve for the future value, so I'm just going to put X in for that. The payment is where I have to be a little bit tricky here. Remember this idea of cash flows. The idea is we're going to deposit $100. So from a cash flow perspective, that money is leaving us. So this money leaves us. And the reason that it's negative is we use what's called a cash flow notation. And so if money's leaving us, it's negative money. If it's returned to us, it's positive money. And so the payment here, negative 100, the interest rate I per period was 4.8%. Remember, in this command I use the percentage instead. So it's 4.8% divided over 12 months. And then in capital N here is just really little n times t. It's the total number of payments, which is 480 payments. And so if I look at this in the calculator, go ahead and bring this back in. The idea here is that if we type in finance or find it in the catalog, then we can just enter the values 0x negative 100 for the cash flow, interest of 4.8% per month for 480 total payments. And you see here that we get the exact same amount, $144,872.14. If I had forgotten about the cash flow and just entered a positive, all it would have done is it would have said we took $100 every month for 480 months, and so we would owe back that much, it being a negative amount. But we'd like for it to come out positive, so as long as we sort of obey this cash flow convention, then we'll end up with the correct sign, correct answer, and everything. So just remember that when you're plugging in the calculator, you use the percentage here, and here you use the cash flow convention of it being negative if the money's leaving you and positive if the money's coming into your accounts or into you. All right, so if we just take a look at what we have, we ended up with the same value here. And so as just a sort of wrapping this process up, you need to be able to do all of this. My suggestion is to not focus so much on the formula, but make sure especially that you can use this finance command in order to correctly identify the future value of the account. And then understand which part is your money and which part is the money that's earned via interest. All right, thank you for watching.